All right, so let's get started. So first, who are we? So today I'm with Andras. I'm Sami Mokadem, and I'm well part of the Circle organization and also part of the MISP project organization. And well, to put it simply, I'm just a developer of one of the developers of MISP. And Andras, what do you have to say about yourself?
Yes, so I'm Andras. We're working the same team with Sami. I'm been leading the development of MISP for the past decade or so.
Yeah, so Circle, basically, we are the third for the private sector in Luxembourg. We are mandated by the Ministry of Economy, and we also lead the development of MISP. So in addition to that and our duties as a CERT, we also run multiple MISP communities. We'll cover some of them later today. Yeah, so that was just a quick and short introduction. All right, so what is MISP? I guess some of you in today's session already know what it is, and you just want to know more about it. And for those who don't know, well, we'll start with that. So MISP is a trade intelligence sharing platform that is totally free and open source that you can find online. I would just say it's quite a mature project because it's been there for quite a while now. As you can see, the release cycle that we have on this diagram is quite high. And it has been following a community-driven development. We'll talk about that a bit more later on. But basically, we really like to have a session with like multiple different user groups to collect their feedback. And based on this feedback, we adjust the development and we prioritize what needs to be implemented in the tools. So that's what I mean by community-driven development. Now, who is using it? Well, a lot of people. You can also see the amount of contributors that we have for that project. And one thing that we really have in our heart is our open source commitment. So anytime a contributor contributes to MISP, they kind of gets part of or they're involved in the licensing, so that it kind of lock the license of MISP into something that is open source and that will never be able to become closed source, basically. So with that, you can be sure that it's not going to be turned into a closed source solution. Now, roughly what does MISP does? What does it do? Sorry. So it basically collects information from multiple sources. It could be from partners, from your analysts, so even your users, or even you. It could be from your tools, from feeds that are either you can find online, or that can come from vendors. And once it says all of this information, it normalizes it so that you can easily manipulate that data. You can easily search for it. You can regroup it, cluster it, and so on. And then it also passes into some kind of processing pipeline when it will create some interesting links, such as the correlation, where you will be able to find related data between incidents, for example. Then the tools also offer possibilities to enrich that data so that you can get more information out of it. And once you have all of this information properly normalized, contextualized, enriched, and correlated, then you can start collaborating on it. So we have many tools and features that allows users to collaborate on the data between them, but also between teams and different organizations, whether they are in the same community or if they are in different communities. As long as there is a bridge between these two communities, the collaboration functionalities will work. And once you have that collaborated data, you can start to export and disseminate this information. So you could, first of all, feed your own protective tools and solution, but you can also disseminate it to partners or other MISP instances. All right, this is just on the right side, a diagram of, it's quite outdated now, but it's just to show you that we have a steady usage of MISP. So we have more and more organizations still using it. This is just a snapshot from one of our instances that we run for the private sector. Now, I've mentioned that we run MISP for multiple communities. We are not running MISP for all of these communities on the slides, but these are the communities that, well, a subset of the communities that we know about that are using MISP rather actively. It's just to give you an idea that MISP is a tool that was originally developed to share malware information, but nowadays is the usage and intended use case is broader than what it used to be back in 2012. So we have the private sector well, for which we participate quite actively that are using MISP. We also have military and international organizations that have very strict requirements, especially regarding security and features such as being able to work in air-gap environment and so on. We also have security vendors that are using MISP to generate their feed and disseminate it to their communities and customers. Topical communities that are really set up to tackle specific issues. One that was extremely popular that we are still proud to have started was the COVID-19 MISP community. So this one started because we were seeing a lot of disinformation campaign regarding COVID, regarding vaccines and so on. And we wanted a way to track this, to track the actors that were doing this disinformation campaign. And so to avoid, let's say, polluting our production instance meant for cyber security related incident, we started that community that got a lot of traction. I don't remember how many organizations we had and how many users we had. Maybe Andras can comment on that. But I remember it was quite successful.
Yeah, we especially early on, we had a crazy amount of usage. I think we ended we stopped looking at it around 3,000 users. So it was pretty actively used and we had a crazy amount of traffic on it. But the idea here is that it's that don't think of MISP as something purely cyber threat intel based. It can be easily adapted for other use cases. So for us, it was also a good little exercise to see if what we're preaching is actually true. So we tried to make it work for something else that had nothing to do with cybersecurity. It did take a little bit of extra development to develop some custom ingestion scripts, widgets, and so on. But we're seeing more and more of these weird use cases pop up. We're going to get back to this a little bit later on when we talk about the different objects and galaxies. You don't need to know yet what that means, but basically different elements or building blocks in MISP. You will see that they come from all sorts of different domains. So don't be alarmed when you see as a selectable object, car plate objects. That's most likely not going to be your use case, but for some communities out there, it is.
Yep, talking about these communities, the next point is the ISACs, where we have a huge community like the telecommunication that is where GSMA is a big user of MISP. So they basically share attack on mobile networks. We also have the aviation control, the retail sector that are really popular communities that have hundreds of organizations part of them. Then to continue and to close that, because we could go on for quite some time now, we'll close with the law enforcement agencies and international groups. So law enforcement agencies, you more or less know who Interpol and Europol are. So they're also users. And international group, I mean, for us, we are member of first.org, which is a really nice community, but for which we also help them run that community. But yeah, other international groups are also using MISP. All right, now more information about the normalization and contextualization part of MISP. So it has been designed, and we always try to keep that in mind whenever we implement new features, to allow you to perform actually threat intelligence on it. And to be able to do that, you have to have context-rich interface on which you can search, on which you can play with, on which you can attach to your data and so on. So from the ground up, that always has been developed like as
design principle.
Yes, a design principle. So obviously you can attach all of this information, but you can also enrich it. We'll see in details in practice how that works. We also have extensive support of threads and TTPs. For example, Mitre attack, that's well known in the community. So we have full support of that. We support many standardized classification. That means you might be already using a classification for your data that is already included by default in MISP. But if it's not the case, we can always extend that standardized classification that's built in by default so that it supports yours. For that, we'll not discuss on how to do it today, but just so you know, it's quite easy to integrate, even if you don't want to share it with us. We have mechanism to curate the data and to have automated quality checks through workflows, CLI, API, and so on. And some visualization that help you understand the relationship between different entities, relationship between threat actors and which tool they're using or which technique they are using, and so on and so forth. That is also supported by reports that you can also create. So these reports are interactive, so you can link to data instead of having it like in clear text into the report. You can actually have references to existing data that you have in your MISP instance, for which you can have a bit of interactivity where you click on these elements, you get more information about them, and so on. And last one is the dashboard that's a system that you can use to build your own dashboard. It's a bit like, you could imagine it a bit like a really lightweight version of Grafana, where you basically have widgets that you can configure to build your own dashboard and well, have it displayed somewhere to show trends, to show activity, to have some errors shown, system usage, and so on. All right, so far we've mostly talked about MISP, the software, so also called MISP core, but MISP is actually also called MISP project, and it's a full project organization that has multiple, let's say, sub-projects. So the biggest one is obviously MISP core, the software, but we could also mention the other ones, such as MISP module. MISP module is an enrichment system that is used to extract or to query more information about your data. So for example, if you would have, I don't know, a domain name, you can use MISP module to perform a DNS resolution and get the associated IP addresses. If you have an IP address, you could use that service to get the geolocation of that IP address. So you get the ID. You basically have inputs that you send to MISP module, and then you collect the output that you can attach to your data. Another one that I will mention is MISP. So MISP has an extensive API that you can use, but sometimes people prefer to use like application wrapper around that API, and that's what MISP is for. So it's basically a Python library that allows you to interact with a MISP instance like you would do using the API, but it goes beyond that because it also helps you to create data totally offline. So to build your event, to enrich it, to contextualize it. And once everything is ready, you just push it in one shot to a MISP instance. So it's really a flexible and extensive library that allows you to do way more than just interacting with the API of MISP. Then the second pillar that we call intelligence and knowledge base. This one regroups mostly all the classification that we have. So for example, the taxonomies or the galaxies that were mentioned previously. We'll see example of what they mean basically. But just so you know, it's just vocabularies that can be used as a classification mechanism that is globally understood and by MISP, but also by users once you start to use them, that are available out of the box whenever you install a MISP instance.
Maybe something to mention here as well with MISP Galaxy in particular. Everything that you see in those lists are coming from maybe mainly two different domains. One is really the classification and standardization part, so taxonomies and perhaps notice lists would fall into this category, whilst the MISP Galaxy and warning list are kind of mixed. So so a huge part of those libraries come from actually the open source community and from research done by various parties and contributed to the library. So you will find anything from threat actor libraries to separate libraries detailing information about specific types of threats, Android, malware, and so on.
All right. Next pillar is the open standard. So if you ever want to integrate with MISP, so if you have your own solution and want to see how what is the MISP exchange core format, so how you can push data to MISP without using PyMISP, for example, or how you could use the format of MISP to exchange information. Everything is described in this open standard. And same for the object templates, because MISP has a very flexible mechanism to create your own data structure that we describe through the object template. So as András mentioned, if you want to describe a car, you can do it in MISP, even though it's maybe now it is actually that we have an object to describe car. But if we would imagine that we don't have one, we wouldn't have one, then creating one is really easy. You just describe the data structure, so what a car is. So it could have a brand, a model, a car plate, a construction year, so on and so forth. You describe all of that, and once you are done with the definition, you can use it.
Yeah.
And what's really cool is you only have to create this definition on one instance. The other instances, if they were to receive the data through synchronization, they would still understand that data and be able to display it correctly and manipulate it correctly.
Yeah, maybe something to mention here. So basically what Sami mentioned works because MISP objects are built up of a set of hard-coded basic atomic elements. So we're going to see how that works in practice. But the idea is that we wanted to remove the actual templating of or building more complex concepts out of the actual standard. So that means that if you have the hurdle that you are dealing with edge cases and you're dealing with threats that are not commonly described by the community at large, you don't have to wait for a standard community or a standard organization to take your ideas and build it the standard. So same thing for us. So whilst our standard is very slowly evolving in a sense that that we are avoiding anything that is backward compatibility breaking, we take our time to add new concepts and so on to the standard. Object templates allow you to circumvent all of this and to build something rapidly that will allow you to describe pretty much anything out there.
Yeah, and to close this MISP project overview, the last pillar is intelligence and sharing community. I will not expand on it too much. It basically regroups all the documents that we produce, so all the training slides that you can also find online, obviously, the best practices that we produce, and also, importantly, the MISP OS in feeds that is available on any new installation that you can just go on the feeds page on your MISP instance, enable the circle MISP OS in feed, and you would have like the feed that we produce enabled and accessible. All right, a short and small diagram about sharing in MISP and how it works. So this one is just meant to show you that you could view multiple MISP system connected a bit like a peer-to-peer system, where there is not really, well, you could have hubs and spoke, but it's a bit like it can be as you wish. You basically have a MISP instance. You choose which instance you want to connect to, and that's basically it. It creates a topology of connected MISP instances. And what we have on the left side of this diagram is if we would imagine that you have an incident. On these incidents, you collect some IOCs. That would be on bank one. Bank one would encode these IOCs into their MISP instance. And then through synchronization, bank one will send it to bank two so that bank two can be protected against these IOCs. But bank one will also send it to the financial ISACs. This ISACs, you can see, is also connected to a national cert, which in turn is also connected to a cert meant for the health sector. And finally, a hospital called Hospital 2 is connected to this cert. And you can see that from one incident from a bank, the information will be shared and transmitted all the way up to a hospital that can later on be protected against this kind of attacks. So even though a hospital and a bank might be totally unrelated, through the synchronization of MISP, they can share information indirectly. Now, a bit more about sharing so that you understand that MISP is all about sharing, but it also offers you really granularity on how you want your data to be shared and visible to whom. So MISP has a multiple distribution level that we will go have a look in detail later on. And in addition to that, it also supports another mechanism that we call sharing group, also called distribution list. So these sharing groups allows you to choose which organization are part of that group. And once this group is defined, only the member of that group can view the data. Already mentioned previously, we support air gap sharing. So you could just export the data on USB key and plug it in another system and import it. It would work as it is. It would be just a regular network connection, basically. In addition to that, we also have feed system, both for ingestion but also generation through PyMISP. And then, since we are talking about synchronization, sometimes we don't want to synchronize and get all the data from the community you are connected to. So we also offer you a mechanism to filter and only get information that you want to have locally. So if you were, for example, to connect to our instance for the private sector, also called MISP, this instance has information from a long time ago. I think it dates back to 2015 or maybe even before, but this is not necessarily information that you would be interested to have locally. So, but just putting a filter on the time and also maybe on the sector or countries that were targeted by some attacks, you can already really define what you want to download locally. Yeah, I will skip some of the most advanced stuff, such as caching or multi-MISP internal enclave. It's not really the purpose. Just so you know, you have a lot of possibilities to define the sharing and how it's happening. Now, about information quality management, this is also extremely important for us because having information is one thing, but making it actionable and so knowing what you can do and what it means is extremely important, as valuable as having the information. So we have many features that help you manage and curate your data. This is just a subset, I would say, of the most important ones that we have. But basically, we have correlation. We'll see in details how it works later on. But the main idea is if you have two incidents or two events, could be anything like a blog post or that you would find online or data coming from a feed. Basically, you would have two information coming from different sources or from the same. I mean, it's very, very flexible. You would be able to see if information is reused in another source. The classical example would be if you have in one incident, let's say an infrastructure, a server is compromised, and a few days later, you see that this infrastructure is being reused. Through the correlation, you will see it right away. We also have a false positive management system through warning list. We'll also see how it works in practice because it's so useful. But basically, it's a system that allows you to flag commonly known false positive so that you don't like share these false positive by mistake. And even worse, you don't put them in like your SIEM or protective tools. Like if you would be blocking something like 8888 in your firewall, this is really well, not interesting at all. It just pollutes your system. Enrichment system, we've already talked a bit about that. The workflow system, we haven't, but it's a system that allows you to define and to create workflows that execute based on certain conditions. For example, you could say that you could create a workflow that prevents information to be shared if it contains, for example, a specific keyword, or if it's tagged or labeled with specific label. So all of this is something that you can create in the user interface that you can enable that allows you to control a bit how information is disseminated or created, but also how it can be improved both by using the workflow and the enrichment system together. Integration, we have a lot of integration. One is also through the MISP module. So you could export data into PDF. You could export it to, I don't know, SIEM if they have integration modules. We'll have a quick look at the different modules that we have later on. So that was integration in terms of tools, but also in terms of format. We have many export formats. So the classical one would be the MISP, the MISP core format. But we also have really basic stuff such as CSV, Suricata rules, Sierra rules, Bros, Nort, and alike. So yeah, integration is so far, for what I've seen, I don't see anything that would be blocking in terms of format for anyone. Now, API, this we'll also have a quick overview of it. But basically, anything that you can do in the user interface, you can also do it in the API. So creating automation through MISP API is quite straightforward. And yeah, for the others, I mean, having timelines, indicator lifecycle management, this also goes a bit with the workflow system that we have. And Jupyter notebooks, who you will see an example today. So quite helpful as well. This is an example to show you a really simplistic curation process that can happen in a MISP instance. So it's like a small summary of what we've discussed so far. So on the left side, it goes from left to right. And on the left side, you have a feed provider that sends data into your MISP instance. Once this data arrive, MISP will create correlation automatically. This data can then be passed through the warning list to remove any commonly known false positive from that data set. Then MISP can run enrichment to extract or to query more information about your data, for example, resolving domain names, getting geolocation, improving the context on this data, labeling it also. Then you can have collaboration through Analysts, through sightings, and so on. It can then be run into a workflow that would further attach label to your data. And once you have this fully curated data, then you can start the publishing and dissemination phase to other users and other MISP instances. All right, we've already covered the flexible data format. Just a reminder that we have this object template that allows you to create any concept that you would like typically IP address, URL, file, and so on. These are the ones that exist by default. You also have like the vehicle that we mentioned, car, planes, same for personal information and so on. So basically anything that you have in mind, you can describe it as a MISP object and you can use it in the application. Now just to give a small overview of the automation ecosystem that we have. Obviously, at the first place, we have the API that also goes with MISP. If you want to have more, let's say, live interaction, we also have PubSub channels. So if you are familiar with Kafka or ZeroMQ, It's basically MISP act as a producer of information. So anything that would happen on a MISP instance would generate a message that would be sent to these channels. You could imagine this a bit like a syslog. And then you can have scripts that subscribe to these channels, consume them, and when something happens that are interesting, then it can run additional, well, basically anything. Then the enrichment, import, export, yeah, this is all done through the MISP modules. We'll see an example of that. And the workflow system I've already mentioned, but it's a quick and easy way to create some simple automation, let's say, where you basically have some triggers. For example, a data is created, can add some condition. Is that data relevant for my use case or for my constituency? And then you can have action. Okay, it is relevant, so I will label it as interesting. It's not relevant, so I will just label it as not relevant. That's basically the key idea of the workflow system. And this is what a workflow looks like in the user interface. Where in this case, it's already using some advanced concept, but in this case, we just flag anything that is known as false positive and remove them as being used to be sent to protective tools. So these workflows, we also have a blueprint library that is available on GitHub. So you can view it a bit like a store on which you can view all the libraries produced by the community, and you can just reuse them locally if you wish. Now, we've talked about sharing, but we also mention quite often the collaboration. And these are just like one of the, well, few of the many features that we have to collaborate in MISP. So we have proposals that allow anyone to propose changes to data created by others. We have analyst data that can be analyst notes and opinion that allows any user, also called analyst, to attach their opinion or note on anything on MISP, in MISP. The delegation system is really one specific feature that is used when you are part of big communities, where you can basically have some kind of pseudo-anonymity in the system, where if you have an incident and you are willing to share the data associated to that incident to your community, but not willing to disclose your name, you can do it without disclosing your name if you use a delegation system and you have a community admin able to take over this event, basically. And then we have other features such as the citing extended event that allows you to extend event to provide more information about them or competitive analysis on them. A sharing group that we've already mentioned to really decide who can view the data and with whom the data should be shared with. All right, this is an example on of what analyst notes and analyst opinion looks like. So we can view this very interesting thread where we have one user that attach a note to an event, the same user attach an opinion on that note, and that's a third time another, well, this same user for the third time that attach another opinion. So we could have a bit of a overview of what these notes and opinion looks like. Now, how would you get started as a new user? Well, you have like two paths. The easiest one would be to simply join an existing MISP instance. So that would be the easiest for you to do. For example, if you want to join our instance for the private sector, you can send a mail to info@circle.lu and ask to have access to MISPRIV, so the MISP for the private sector. And at that point, we will provide you credential and you will be able to access that instance, view all the data created by the community and download it locally. If that's the next step, to download it locally, because you can just download it like as JSON or CSV, but you can also download it into your own MISP instance. And that would be the second path, so to host your own MISP instance. So once you have your own MISP instance, you have access to many features that are locked compared to if you were to join just another MISP instance, because if you do, you won't have access, for example, to decide which feeds are enabled, to which instance you are connected to even run workflows. These are features that are meant for site admins or administrator of a MISP instance, which we definitely won't give you access if you were to join our community. But if you host your own MISP instance, that you get access to all these benefits. And you can also configure synchronization to our MISP so that you can have access to all the data. So it's that's the whole idea. And now as a driver, but this is really, let's say, special case. If you want to start your own community, just the three main guidelines that I would keep in mind before starting is to estimate the requirement and objective of that community, to decide which vocabulary and classification to use, and also to think on which service you want to offer to your member. So if you want to propose enrichment, if you want to propose curation of the data they create, if you want to propose delegation so that they have pseudonymity, this is few things to keep in mind before starting. All right. Yeah. One of the last slides, future of MISP, what's ongoing and what's going to be. I think this slide is a bit outdated. Huh? And I see Andras is already laughing about it. Do you want to provide more information, Andras?
Yeah, so basically a lot of what you're saying there, I mean, I would love to say it's not long-term anymore for version 3.0, but taking way longer than we thought. But generally, we're working on quite a few things currently that I will go into both the next version and probably also into the current one. So in the 2.5, we're currently revamping a lot of the internals of MISP. So expect some changes there on the short term. So whilst 2.5 is out, and I hope that most of you that are running MISPs are already on 2.5, there will still be quite a bit of new things coming to it before we move on to 3.0. But that will be the next big thing, which will be a complete rework of the user interface, as well as moving into a more analyst-centric perspective. So some of the things that we're currently working on is having different approaches of where you start investigating and looking at your data. Right now, this is really fixed in MISP. That is something that will change with the upcoming release of 3.0. So stay tuned for that. For the enhanced performance, since some changes we've made since the slide was made, that is already happening now. So we're since we're going to be...
Yeah, but a lot of things have already been changed. Like the front-end aesthetic, this has almost not been touched. Well, at least not publicly. We have some project on the side that on which we have made good progress, but it's not something that has been made public yet. But the improved search analytics and enhanced performance, this has been already improved quite a lot. And analyst-centric perspective, this has started. We have many good ideas that for which we already have started to develop things, but it's not there yet. All right. Yeah, this is just side notes. We have some professional services that we offer because we know some organizations have issues or cannot simply take or use software that don't have support or that don't have official professional service available. So just so you know, if you are that kind of organization, we do offer support contracts as well as training and hosting. But that's just good to know. All right, that's basically it for the introduction. Now, if anyone, yes, I see many people have joined since we started. So I will paste the URL of the training document in the chat once again. On this document, you have access to the training instance that you can see on the screen right now. You can pick one of the username that is inside this document. So you could say, for example, user12@org-admin.main.test. And the password is also written in that document. It's MISP_training_VSS. And then you can log in and you can play with that instance. So you can create data. You can just play with it, discover the application.
Yeah, just please don't change your password. Because obviously we have quite a few folks online. We're going to have more than one person logging in per account.
Mm-hmm.
Be careful with that.
It's not a big deal if you take the same user account. Just, I mean, if you change the password, that's not cool. All right. So, Anders, would you like to describe a bit the user interface? So what are we looking at right now?
So what Sam is showing currently is what you're going to be seeing when you first log into the system. This is what we call the event index. We haven't really gone too deep into how the data is structured, but basically think of it this way. Each one of those entries that you see there is a specific incident, event, or a collection, or something that is contextually linked, described in a container. So these are all the different contained data packages that we have. You can already see some meta information immediately when you look at the index. You see who produced the data, that is the creator org column. The owner org you can ignore for now. That is normally not something that users see. It's only for administrators who can currently manage the data on the instance. And then you finally have different labels and meta information that are contextualizing the data. So you see, for example, here we have a bunch of different tags. Those are on the right side of the context layer, so the third column. And then on the left side, you have the galaxy clusters. We'll go deeper into what they are in a bit. For now, suffice to say, both of these different lists are just giving more information to us about what the contained events are. There's also a description of each of the events. So this is actually the only requirement to create a new event in MISP is having a description. We'll see that during the API part, that's the most minimalistic approach. And then finally, we have the distribution level of the event. So this tells MISP, who can I share this information with? Now, all of your users, if you have logged into the instance, belong to the training organization. But normally, if you were on a live operational instance, your user account would be tied to your organization. And whenever it comes to access control in MISP, the most basic building block that we adhere to is the organization. And so we're going to get back to this in just a bit when we're creating our first event. But think of the most basic building block for ACL being an organization. Okay, so each of these events contains a bunch of different data. So here we have a column enabled currently that shows us a number of attributes and correlations for the data. And I see some already pivoted to the actual view of an event. So let's move over to that. So currently what happened was Sami clicked on view on one of the events. And we see here that, that we see the same metadata as what we've seen on the index with some additions that we haven't seen before, such as the threat level information, the status of whether the event is protected, and so on. So a bunch of different meta information here. We also get something that we didn't have in the previous screen, and that is all the data that is contained within this event. Now, we generally differentiate between two types of data, or two main types of data. One is basically giving context to the data, to the information we're sharing, and one is the actual data points and the meat of the data package. So that second part is listed below the meta information that we've already seen. So here we see the list of the different data points that are within the event. each of these lines represents one atomic building block, so or basic element that we call an attribute in MISP. Think of it this way: an attribute could be an indicator of compromise. It could be a link to additional information. It is simply one piece of data that is either describing something in a self-contained way or is part of describing something more complex. Now, these attributes can be composited into what we call MISP objects. So these are those blue borders that you see around a set of attributes. Here we see, for example, a file object that has 6 total attributes further describing the file. We see the actual sample that we can download, so cryptolocker.exe in this case. We also see additional information such as file hashes, file size, and so on. And then we see that that these different objects can also further be interlinked with one another. So if you look carefully at the blue line on top of the object, so the header of the object, you see that it is referenced by other elements within the event, and it also references a set of other elements within the event. Okay, when it comes to each of these attributes, let's look at maybe a basic one on top. So I think we had an IP type attribute that is loose. So let's look at that one. Yes, perfect. Yeah, there we go. So now let's look closer at how one of these attributes is constructed. As you can see, there are basically 3 main fields that are describing what this thing is that we're looking at here. There's a category which gives it a rough context, where generally it's not that important these days as it was back in the day. Nowadays, we give context via tags and via galaxy clusters rather than the category itself. But it still limits the use of the attribute that is being described here. So in this case, we're looking at something that is used for payload delivery. Type tells us how that concept is expressed. In this case, it's expressed as an IP source. And then we have the actual value, which is our IP address. Now, if we scroll a bit further right, we see that besides these 3 data points, there is one other crucial piece of information a bit further right. There we go. That is describing how this data point is to be handled by MISP, and that is this IDS flag. That tells us whether this combination of type and value is actually something malicious that we want to alert, block, and so on, or if it is purely there as contextual information. Now, keep in mind that the line is kind of blurring between indicators and contextual information when it comes to things such as cleaned up malicious hosts. So even though you don't want to directly alert on it, it's still useful information to have when you're doing your analysis to the fact. So it's not an indicator directly anymore, but it is still useful information. So sometimes when it comes to calling it an indicator or not, it becomes a little bit tricky in these edge cases. We also see that attributes themselves have their own distribution level, similarly to events. Same thing with the objects themselves. Just below, we see an example of an object having a distribution level as well. This tells us that MISP has a hierarchical access control system. That means in order to be able to see an attribute, I need to be able to see the event that encapsulates it. And if it's an attribute that is part of an object, I need to be able to see the object as well. So we have this hierarchy of event, object, attribute, and you have to be able to see the full chain to see an attribute. But this also means that you can add additional restrictions when you're sharing information. A very common use case is that you would share an event where you would say that most of the technical information should be visible to my large community of different organizations, but I would perhaps keep information about some of the target of the attacker information to a smaller group, and perhaps keep information about the victim just to my own organization. So this can all be configured on an attribute by attribute basis if you want to have more control over where the data flows. Yeah, we're also going to see that there are more complex ways of setting a distribution as well, called sharing groups. We'll get back to those in a bit, and those are basically just distribution lists. of recipients. Okay, now we also talked a little bit about the contextualization when we were looking at the event index. We saw those two columns, the galaxy clusters and the tags. Those things also exist on the attribute level. So that means that whenever you're contextualizing data, you can do it on the envelope itself, or you can contextualize individual data points. This becomes especially interesting when you're describing an incident, for example, that has multiple stages. When you're thinking about attack techniques, obviously you're going to want to enumerate what techniques were used during an incident or an attempt to the attack. But you also want to differentiate for each of the data points. For example, in this case, we see that we have a bunch of additional information about cryptolocker.exe in particular, and that information may not be valid for the for other parts of the incident. So, for example, if you have an initial attack vector, describing that separately from the other data points can be done this way. Now that we've seen basically what an event is, data layer is made up of, let's look at some of the things that we missed on the context layer. So we've seen that on the data layer, we have attributes, we have objects. And on the context layer, we've already seen that we have those simple labels on top, and we have the galaxy clusters. There's a third, there are actually two more things that we're going to be talking about after this, but briefly to mention the main difference between these two things. You see that both of those are, in effect, just labels. And when it comes to searching data, when it comes to labeling data, we see that cryptolocker is mentioned as ransomware galaxy cluster. But if we look back at the tags, we also see, for example, if you go to tags for a moment, that we have ransomware as a classification defined. Now, these might seem as equivalent types of information at the first glance, and they can be used in a similar way. So they can be used, both of them, as basically just tags. But the galaxy clusters do something else in addition. They contain a lot of information that is shared across different events that further contextualize our event. So let's have a look at one of those galaxy clusters just quickly. So here we see, for example, with cryptolocker, well, there isn't that much information there. In that case, perhaps showing an attack technique or the spear phishing template below. Oops, doesn't matter, just any of those will work. You can see that you have a bunch of additional information in addition to just the name of the tag itself. So you can have a full key value store of data points within a galaxy cluster. Oops. So here we see in the example that we saw there, we saw that you had some additional data points listed below. Those are freely definable if you're creating your own galaxy clusters, and you can reuse these knowledge base elements across different events, different attributes, and so on. And they're basically also first-class citizen objects. That means that they can also be published on their own to a community. Okay, there are two more main contextualization elements that we haven't talked about at all yet. One of those is called event reports. So these are basically clear text descriptions of something that is related to the event. Normally, what the types of usage we see for this is a summary of what happened, or very often we start our entire encoding in MISP from, say, ticket in our ticketing system that we would then transfer as an event report, or from an OSINT report that we would use as our starting point. So here is such an example of a highly defined event report. Here we see everything from technical data, images, an attack heat map. All of these different data points are also stored in attributes in our case. So everything that is highlighted is actually an attribute or an object in MISP. But this way we can give it a more coherent framing, and we can let the human reader of our event understand what the intent of this event was. So this is something where we can pause maybe for a moment and talk about the two main use cases of MISP, or different use cases. One is basically speaking to other humans, and one is speaking to machines. So when it comes to attributes, they're very tightly typed. So when you were looking at the IP attribute that we've seen in the beginning, that thing has to have a certain format in order to be valid. And because it has such a tight typing, it can be used to be transformed into, say, network detection rules. On the other hand, when we're talking about how we speak to humans on the other side of our MISP, basically, and then we also have to think about clear text descriptions of what is happening to give humans an idea of what the incident entailed. And event reports, comments, and the other thing that we haven't talked about yet are basically all meant for human consumption rather than machine-to-machine consumption. So now that we've seen event reports, the last piece that we haven't talked about is analyst data, but we're not going to go too deeply into that now because Sami has already shown that a fair bit during the introduction with an example. But that is and the final piece of meta information that you can share along with the data, and that is fully collaboratively contributed, so it doesn't have to be coming from the producer that produced the event. So now we've seen basically what an event looks like. So now we understand the main concepts of what we're dealing with here. So let's start by creating an event of our own and see how that process works.
Yeah, and for that, should we take an example like the simple spear phishing?
Yeah, we can do that. So that should be in the link that you pasted, if I'm not mistaken.
No, I forgot to add it, but hold on, I will do it. I will modify right now. So if you want to try it out and copy paste, it has been updated. All right.
Okay, so I encourage you all to have a look at that.
So basically, this is a fake spear phishing incident where we have a bit of context. So let's quickly go through it, and then we'll try to simply encode whatever we have received so that it can be used and shared with a community. So the thing is, we act as a CSIRT, and we receive a mail from another CSIRT. Unfortunately, these guys, they don't use MISP yet, so they send all the IOCs and contexts by email, which is not very convenient. So what we'll do, for the sake of helping our community, we'll encode whatever they send us to us into MISP so that we can easily disseminate that information. So this is the mail that we just received. So they say that they had a failed spear phishing attempt targeting their CEO with the following details. So their CEO received an email on that specific date time about a report card for their child. So it's really targeted spear phishing. And the attacker pretended to be working for the school of the CEO daughter, sending a mail from that spoofed email address, where Mr. John Doe is the teacher of the student. That email was received from this domain associated at the time to this IP address. Also, as you can see, we don't have the actual email that was sent, which is a shame. So for that, we'll have to ask them by email to provide us that email, which you could do. You could request it in MISP, but yeah, right now we have to deal with emails. Then the email, the original email that we don't have, contain a malicious file, but this time we have it. It's there. That would try to download a secondary payload from that URL. And we also have it downloaded. It's the second sample. And at the time, that domain was resolving to that IP address. Once you execute that secondary payload, they say that it's trying to exploit that specific CVE. And after a bit of analysis, they also noticed that the secondary payload also has a hard-coded C2 that is exfiltrating local credential at that URL, which was also resulting to that IP address at the time. And finally, they closed their mail by saying this is how far they've gotten in the analysis. And they basically ask us to avoid informing the attacker of the detection. So basically, do not scan back the attacker infrastructure. Yeah, so based on this mail, we can extract some information. For example, the email provider, the IP address of that email provider, 2 payloads, 1 URL, 2 URL actually, the URL used to download the secondary payload and the URL for which that is used to exfiltrate local credentials, and a CV.
For brevity, we're not going to do this all of this now, but we're going to at least encode 1 or 2 of the data points from the list. Now, before we start, there are multiple ways of approaching this issue. So we're going to kind of look at the same context, so this spear phishing example, and we're going to start with 3 different ways of how we encode this information. So let's start with the first one, the one where you have the most control over creating the information, which is encoding everything by hand. So we're going to start by clicking on an add event, if you want to play along. And here we are going to first describe our high-level information about our event. Now again, you can set things such as a distribution at this point already, who the data is going to be shared with. This will partially happen immediately. So the moment you're creating something that is not your org only, any other user of the instance will be able to see the data. So if you want to keep it private at this point, you can start out with a very strict distribution level and then loosen it up once you are ready and your data has been vetted, gone through whatever checks you have in your organization. And all the other options can allow other organizations, depending on the setting, how far away from you, basically, to distribute the information based on the spirit or the restrictions of the distribution level itself. So let's start now, in this case, for the organization only. That's a good starting point if you're unsure about whether you're going to end up accidentally disclosing something. This is a safe way of starting, basically, because it's only your organization that will see the data. Data will not synchronize out, and no other organization can see our data in this case. We basically have 2 fields called threat level and analysis after that. These are not that interesting at all. So these made a lot more sense when the user group of MISP initially was more coherent. So we basically had only like 1 or 2 different types of organizations, so national certs and military certs, in our small community over a decade ago. And then these settings were more easily understood and were more uniform across the board for the different organizations. Nowadays, if you go to the fraud team of a bank, for example, and you tell them that you set something as threat level high because you saw that a 0-day was exploited, they will not even understand what you're talking about because they're in a completely different field. So because of this, we generally don't use these fields, or we don't pay that much attention to them in general. But you can set it up if you want, or you can leave it on the default setting. However, the most important thing here is the event info field. So this is the one that will give you a one-liner explanation of what you're dealing with. Just some hints here. Please don't use any internal references here, even if you are only keeping your events for yourself. In the future, you might decide to open things up and share with a broader community. So if you just put a ticket ID in there, it's going to be another pain for others to sift through your data and understand why you were sharing that information in the first place. So generally, having a short, clear description is the best practice, as well as generally sticking to English helps if you are later on joining broader communities. So I myself, for example, am Hungarian. If I would put Hungarian titles on my events and share it out to a broad community, I would get a lot of confused responses. So to avoid that, yeah, stick to the most easily understood language. For extended events, we're going to look at them in a moment, but not just yet. So let's click submit, and we have our event now created. So now we have a basic envelope, and MISP immediately tells us that a lot of things are wrong still. We're missing context, obviously, content, we're missing context, and we also don't have our event published yet. So we get all these red warnings at this point. So let's start populating our data. Let's start with the content part first. Let's look at our spearfishing example again. There we have seen that we had, for example, let's start with the IP address of the email provider as a simple example. We saw that we had an IP address in there to want to encode. This was used to deliver our spearfishing email. So let's try to add this in MISP. We have multiple ways of doing this. Let's start with the most basic one, which is called add attribute. You either click on the left on add attribute or a little plus sign above the attribute window. And that allows us to create an or a list of attributes that have the same type and category. So this is the most confusing way to start out with when you're new to MISP, because you need to understand what categories and types exist and which ones belong together. So in this case, let's start with the category. We know that we're talking about the initial attack vector, so let's start perhaps with payload delivery. And then as a type, we have IP DST. Yes, so now we have an IP address, and then we can paste our IP address into the value field, and we can tell our MISP that this is something malicious or something that we want to detect on, so we check for intrusion detection system. We could add multiple IP addresses in one shot, so if you have a list that you want to add, you can do line-separated values, but you have to then click on batch import, and then each of those will be ingested as a single attribute. So now that we're happy, we could additionally set things such as first seen, last seen, though they're pretty straightforward. We're not going to do that now. We're just going to hit submit. And now we have our attribute created, and a bunch of stuff happened already now. So you see that not only is our attribute now created, we also have relations set. We could also, for example, if we add another attribute quickly, we had 8888, we would get not only correlations, but we would also get warnings about the attribute. So we see that MISP already did a lot of processing at this time. It cross-checked all other events on our instance. It cross-checked all the feeds that it has cached to see whether those values exist anywhere else. So now we see that all the related events on top. So now we have both of those things. So maybe we get back to the correlations in a moment. Let's start with the warnings instead, so we can delete our quad 8 IP address. So here we see that 8888 is flagged as a potential false positive. It's a known DNS resolver. It's a Google DNS. So MISP tells us this thing here will cause issues if you start throwing that in your IDSs and your seams. You're going to end up with a lot of alerts. So it flags it as a high likely false positive. Now, whenever it comes to ingesting data from MISP, this is just a small side note. We're going to see it during the API part. You can tell MISP to exclude anything that is an obvious false positive like this one. However, it's best practice to, in this case, unset the IDS flag or to remove that attribute. So let's remove it for now so that we can actually look at the correlations. Oops. There we go. So if you look at our correlations, here we see all the other events. So this is obviously going to occur quite a few times on this instance, since it's one of the basic things that we show during trainings. So you see that it's cross-correlating with other events, but this already can give us a lot of information when we are dealing with an incident. We could end up seeing correlations based on some of the data points that we're encoding in our initial ingestion round to previous cases that had some commonalities. So this can already give you a leg up in your analysis process by examining similarities or across what your community has shared already. Some good other examples of use cases of such correlations. If you remember the hacking of the Democratic Party back in 2015, 16, and there was a massive report published by DHS at the time, which included a bunch of IP addresses that were actually Tor exit nodes. The moment we encoded that event into MISP, we immediately saw that they were Tor exit nodes because it immediately cross-correlated with an event that we use as a master list for known Tor exit nodes. So we could immediately rule those out as things that were indicators in themselves. So there are a bunch of these kind of use cases that allow you to basically make your own analysis process easier. Yeah, that's it for the correlations. Now we have our attribute encoded. We could have done this differently. So let's look at the second way of encoding attributes. So as you've seen, this is super slow. So besides me just talking a lot, this was also a painfully slow process. We had to select a category, we had to select a type, we had to check all those things. And we had to have a lot of knowledge up front in knowing what categories and types exist in the first place. There's another way of starting, which is called a free text importer. So let's look at that method now. So let's click on our free text import button. And let's take a part of the text and throw it in there so that we could extract it. So maybe take the second paragraph. That's the third paragraph.
Yeah, sorry.
Sorry. Perfect. So here we see that MISP will use the free text importer to rip out anything that it thinks is an indicator. So this allows us to be much faster because it already pre-categorizes and pre-filters everything that might be an indicator. But on the other hand, it means that we need to do a little bit more work at this point. Okay, currently, we're lucky. The 3 things it picked up are actually valid data points. But you might end up in a situation where it picks up, for example, a security vendor's own domain that was in the header of whatever you copy pasted. So that's not something you would want to store as an indicator. Or sometimes it will also miscategorize things. It's not exactly a very advanced system that's sitting behind the free text importer. It's basically a long list of regexes that we use to filter out indicators. So it might make mistakes there too. So you might need to do additional work when it comes to checking the data. It's kind of like working with AI nowadays that you basically front load the work that it can do for you, and then you end up with just as much time figuring out what went wrong. So here we have now selected 2 attributes. We can do some last minute refinements. It will give us all the valid types and categories that could be valid for that value. So in this case, for example, that bottom one could be a domain, but it could also be a file name actually. So maybe, so it gives both of those as an option, and it thought that domain was more likely. So it picked that as the first option. So once you're done with refining everything, you just click submit attributes, and it will create an attribute for us. Or 2 attributes for us in this case. Now let's delete those 2 attributes quickly. So now we've seen how to add it this way. And let's do the same exercise again with the free text importer again, but now we're going to do it slightly differently. Yeah. Just paste the same one. And now we're going to try to just capture the things that belong together and create an object out of them. So in this case, let's get rid of that first one. That one doesn't belong there for now. And the second basically are a domain name and an IP address that it resolves to. So those things belong together. So in this case, we could use create object. And we could pick domain IP as our object type. Now, with this, we're telling MISP that these two data points that were detected belong together. And we use a template that fits this pattern of these two attribute types. And if we click Create Object now, then we also have our two attributes created, but they will be encapsulated in an object. So this in itself gives us quite a few advantages over just encoding attributes. Objects are much better suited to create graph-based events. So we're going to see how that works in just a bit. It also allows us to give an additional layer of contextualization by default. In this case, it's a pretty bad example because we see that we have an IP and a domain, and the relationship to the object is basically the same as the type almost. So we have domain, and IP, DST. Not that interesting. But for example, if it comes to things such as describing persons, then we would end up using the text attribute type for a bunch of different things: first name, last name, perhaps address, whatever. These would all be described by a text attribute type. But because if we load them into an object, we can still mark the relationship of that text attribute to the object itself. So for example, we could say that this text attribute is describing the first name of a person. So that gives you an additional layer of contextualization right there.
But we can do it like as an example, encode the person that you mentioned, so that we also see how we can create an object.
Let's go for that, indeed. So let's now create an object from scratch, similarly to how we initially created an attribute. So by starting with an empty template, the way it works is we basically have to first select what template to use. This can be super confusing at first because there are a lot of different templates there. What you see here are all object template categories, basically, that all contain a bunch of different object templates within. So if you look at, that's big file.
Just a tip that I'm gonna use, that I'm going to tell you. So I never know in which category the objects are. So I always pick all objects and then use the drop down to search for one. So I know I'm searching for person, so I will just search for person.
Yeah,
and then I will see, okay, FTM person, this is part of follow the money. This is not what I'm really looking at, but I see person there. And if I hover over the icon, it's an object which describe a person or an identity. So this is the one I'm actually looking for. So you just click on it and there you go. So you don't need to remember the categories.
Yeah, that's indeed a handy shortcut. So now we see here that we now see a template in front of us with all the different fields that can be part of an object template. As you can see, there is quite a few different options there. However, we don't need to fill everything out. What we need to do is described at the top of the object template. So here we see requirements. In order for this to be valid and savable, we have to have at least one of those things that are listed there. You will see some templates require multiple things. So you might end up with a list of requirements that are not required one-off, but all of them are being required. Think of a domain IP. A domain IP without a domain or an IP wouldn't make that much sense. Although I think we actually allow
it's one-off. You
Yeah,
can just have the
yeah.
domain.
So that's maybe something we might want to tighten in the future, but it's a different discussion. But in this case, it's quite lightweight what we need. So if we look at our example again, for our spear phishing example, we see that there is a person that is being spoofed, that is pretending to be the teacher. So we see that the name is John Doe, we have an email address, and we have, in this case, some additional context that we'll use later on after we've encoded it. So let's fill out the fields that are relevant. Teacher, perfect. And then you have an email address. That's it. Okay. So now that should be enough. So now we filled out everything that we had as information from the email, and this will now create an object for us with all of the different data points that we've listed there. The interesting thing with this is when you're using a template is all those choices about categories and types in object templates are hard-coded based on the template itself. So you don't have to worry about it when you're encoding it. Here's also a good example of what I mentioned before. We see a text attribute type that has a relationship of occupation to the object. If we didn't put this in an object but had it as a loose attribute, just having text teacher as an attribute wouldn't give us much context of why this is there, which other data points this belongs to. This way we get a nice coherent package with this object describing a single person. Okay, so so now we've seen two different ways of creating objects. We have seen the way where we took a part of the free text import and we converted that to an object, or everything that was parsed out. We've seen the manual creation. There is also a third way, which is, for example, if you create two attributes, google.com and 8888, is to combine existing free floating attributes. So wait for Sami to create it. There we go. So now we have those two attributes there. We can also start from this point and just start with a bunch of flat attributes and then further build our event out by grouping them into objects. So now we've selected those two, and MISP will give us a list of things that it can use as an object template where both a domain and an IP are contained. So Sami has selected domain IP, and now we create our object. And now those two attributes have been moved into the object itself. Okay, so these are basically the main ways of creating the data, but there is one more that is super handy and that I really enjoy, which is starting from an event report. So let's add an event report to our event. There we go. Here we can just load the entire initial email that we got from our friends that let us know about what happened. And we can do some cleanup there, click submit. And now we have our data loaded into an event report. Now let's do some final cleanup here. Because of the indentation, it thought that it was actually a quote, but we fix that now. Whenever you're coming from say ingesting HTML or something else directly like this, you will have to do some cleanup on it if you want it to look nice. So once you're happy with it, you basically now have a text that is describing all the different data points that we've already talked about. But we can now tell MISP to take this text and rip everything out, create attributes and objects out of it, and also interlink it with this report. So this is called the extraction. Let's go for let's go for manual extraction. Now it's
so what we have.
Yeah, because they're already also.
Yeah. So Andrash is a bit confused because we have some replacement accessible. So we have two things. The extraction will actually do what the free text import tool does. So it will create attributes out of the text. But the replacement part is there because these attributes already exist in the event. So we don't need to create these new attributes. We can just add the reference instead. So for example, this one, throw email provider, if you click on it, you could simply say that instead of having the throwaway email provider as is inside our report, so as raw text, let's say, we can have the reference. And so if we close the extraction view and we look at what actually happened, instead of having the throwaway email provider text as is, now we have a reference. So we say that it's an attribute and we have the UID of the attribute. So you could also work from this interface to do the referencing part or the automatic extraction. Like this extraction, for example, this CVE that is there, this doesn't exist as an attribute right now, but if I click on extract and save, it is going to create that attribute and create the reference in the document. If we look now at the document, we can see that it's actually a reference and not the CVE 2015 5465. And if we go back to our event, you can see that the CVE was actually created.
Okay, so now we've seen different ways of creating data in MISP. Now let's quickly look at how to interconnect these data points with one another. So generally, you could do it from this tabular view. I absolutely hate doing that, so let's not do that. Let's instead move over to a different view altogether, which is the graph view of our event, and let's work with that. I highly recommend that you do this, either script it and create the relationships via script if you're ingesting data from a sandbox or whatever in a standardized way, or use the event graph. Here what we see is we currently have some unreferenced data points that are currently just loosely floating around in our event. So we see we have two objects and an attribute. If you click on a data point and press X, it will explode it, and you will see what's contained in those nodes. So here we see our throwaway email provider via domain IP object. And we also have our person object sitting next to it. Okay, now let's say that we wanted to connect these two data points with each other, so the person and the domain IP object. We could flip over into edit mode on the left side, and then click add reference and simply draw an arrow from the person to the domain IP. And we could say uses, for example, as a selected relationship type. Yep. Right. And now we see that we suddenly have a graph where we have a relationship between these two different data points. You also have a non-reference attribute that can also be used in our graph. However, only as the destination of one of those relationships. So that's a shortcoming of attributes. So whenever you want to have a better way of interconnecting all your data points, just use objects for everything. So now we can say that this person is using this vulnerability or abusing. Maybe there's an abusing, I don't know. Doesn't matter. It's a little bit delayed for me, so I see a risk.
Oh, yeah.
Sorry. Okay, so this is basically how you build build out interactions between your different data points. I highly recommend that if you have the time, take your time to do this whenever you're describing something. It gives a much better idea to whoever is reading your event to understand the flow of an incident or the execution of a malware and so on and so forth. Now we're done with the data layer part. Let's quickly look at how to contextualize our data. Very straightforward. We basically have two levels of doing it: tags or galaxy clusters. Let's start with tags. Tags generally in MISP come from what we call taxonomies. Taxonomies are basically libraries of different labels that belong together. For example, things that belong together could be something where you have a very scoped, self-contained vocabulary such as PLP or PAP. Those would then have their own individual tags within the taxonomy. Or you could have something more complex. For example, we're maintaining a circle taxonomy for a bunch of different things that relate to incidents. So there are a bunch of different libraries to choose from. So something that is really confusing here at first is you see that there are two plus buttons next to each other, one with a little globe and one with the person. The first one we call a global tag, and the second we call a local tag. So the main difference between the two is the global tag becomes part of the corpus of the event. So that means that whenever I'm sharing the event out, this tag will carry along, will be carried along with the event, and it is part of the event itself. Local tags are different. They're just labels that we attach to an event while it is sitting on our instance. It can be used for flow control, for example. You can use tags to decide what event gets synchronized in which direction, or you can use it for filtering when you're exporting data and so on and so forth. Now, the main difference between the two, besides the synchronization part, is that one actually modifies the data. So that means whenever I'm adding a tag to data, data gets unpublished and it receives a new timestamp. Local tags work differently. They are just temporary things that are assigned on top. It doesn't actually change the event. So let's go with a global tag. We want to add a tag that becomes part of our event. And let's add a TLP label, for example. So here you see similar concept to what Sam mentioned before. You can either select the library that you want to use, or you can just search everything. I'd advise to, contrary to what Sami does with objects, to here select a library because there are a lot of tags. And if you go for a search among the entire list, it's going to take a while and it will blow your browser up.
Yeah.
So
for me, for this one, I never use all tags. I always select the library because I already know in which library the tags I want to use are located in. Like we want to add a TLP tag, it's going to be in the TLP library. So I will just type TLP and I will have it show up in the dropdown.
There is one exception, which is not all tags come from libraries actually. So you don't have to have a tag belong to a taxonomy. You can create ad hoc loose tags. It's especially useful when you're doing something on an internal instance where you want to have some flow control. For example, a typical use case is a vetted flag, and that you would add to events when your senior analyst is done with the event, and it's ready for publication. It's ready for publication to other communities. And for the sync filters, then you would require vetted to be set in order for the event to be synchronized out from your instance. That's an example. So let's add the TLP tag for now. So TLP Amber, whatever. Now we see that that now we've labeled our event. It suddenly becomes searchable by TLP Amber. So suddenly, if we search for that tag via our APIs, via the UI, whatever, this event will now be listed. It can also be used as a filter mechanism. We could say, for example, that when we're synchronizing with another partner community, where we have a stricter relationship of what we can share with them, in that case, we could use TLP Amber as a filter to remove this event from the dataset that would be synchronized. We can do the exact same thing on attributes. Attributes also have their own way to add tags. We could add, for example, in this case, a TLP red tag on one of the attributes. For example, just take the fact that, okay, whatever. Let's pick one. There we go. So now we have the vulnerability marked as TLP red. It's probably the most counterintuitive way of labeling an event. CV TLP red, personal data not, but okay. So in this case, we now have two conflicting TLP tags, one on the event and one on a contained attribute. We can use negative filters whenever it comes to both synchronization and filtering to say, just remove everything that is TLP red from the dataset. So we would get the full event minus that one attribute. Okay, now let's look at galaxies. Same concept is just stored in a different place on the page. Local and global galaxies that we can attach. So let's start with a global one. Galaxies are divided into a set of concepts or libraries. These very often either come from an existing standard, such as MITRE tag, for example, or they describe a more generic concept, for example, threat actor would be one. Okay, so let's go with...
For this one,
speak.
Same for objects. I never know in which namespace they are, so I always pick all namespace. But for the actual name of the galaxy, this is like super important. So like if we want to describe that this event happened in Luxembourg, for example, I would search for the country galaxy in that dropdown, because I don't want to have all the possible entries that we have in all galaxies. So I will just take the country galaxy. And finally, there I can select, for example, Luxembourg.
Now, something interesting here is obviously sometimes you won't have the exact name in mind that whoever encoded the galaxy had in mind, especially with threat actors. If you've ever dealt with threat actor naming conventions, it's not a pain. There is usually a lot of overlap between what different vendors publish under different names. So if you know one of the names, you don't need to know the canonical name that MISP uses. You can search by any one of those, and they're stored in what we call synonyms with the key value store of the Galaxy clusters. So if you search for Cozy in this case, it will find APT29 because of Cozy Bear being one of the synonyms. So just start searching around for the thing that you want to encode, and even if it's not an exact match, you will probably find it under a synonym. Okay, so let's just attach something. Perfect. So now we have basically created our event. We have added attributes, objects, tags, event reports, Galaxy clusters, pretty much anything, and we're ready for publication. At this point, our event is still inert. That means if we have tools that are siphoning data out of MISP and using it for building detection rules or blocking rules and so on, they would not find this event for now because it is not published. So in order to publish an event, we have multiple ways of doing it, but let's look at the most straightforward one. We just click on Publish Event. Oops. And now our event is published and things happen now. Let's go through the list of those things that just happened. First of all, the flag changed to published. That's the most simple one. Suddenly, it can be picked up by all our different APIs and searches. Suddenly, our seam that is feeding off of our MISP is getting this event. There's another thing that happened. We also initiated the synchronization of the event. So if this event were to be synchronizable, it is not currently, then it would synchronize out to other instances based on the rules that we have described. Third, if we have any tools connected locally to MISP, they would be receiving this information. We have multiple channels through which we push the data to other tools. One such channel is 0MQ, Kafka, and we can also push it via syslog. And I think we also have one for
Elastic.
For Elastic, yes, and something with AWS. I guess 3 buckets we can push there directly, but I'm not entirely sure. So anyway, we have this happening as well at the same time. And finally, we're also notifying users via email that this event has been published. If they're subscribed to email alerts, they would now get an email that there is a new event in your instance. A small side note, little known fact, you can configure publication filters on your user. So you could configure for only certain threat actors to be hooks for you to get an email. We're not going to go too deeply into that now, though. Okay, so at this point, our event is gone. It is now synchronized to everyone and usable by everyone. At this point, if we were to make any further modifications, the event would get unpublished, so we would have to go through the process of republishing again. Now, if we, just make whatever modifications so it gets unpublished.
So I will enable the IDS flag of .cv.
Perfect.
And now we can also come back to one of the questions that was asked in the chat. Why do we have this red and bold font? But that was like almost 1 hour ago. So this is because this data has changed since the last publication. And so this red indicates that this modification is pending publication, basically. So now that we have modified that attribute, we can see that the publish flag has been switched off. It says that the last time it was published was at that time. And the only thing that we need to do in order to make this event accessible to our local tools and to also propagate this change, the possibly changes to other connected MISP instances, we need to publish it again. But this time I will change the distribution level to something a bit more permissive, like connected communities, so that you can see what happens. So now I will, instead of doing a publish event, I will just do a publish no email. The difference is just that I'm not going to notify users again, so that I don't spam them, basically. And you can see that publish but do not send alert email. And you can see that if I press on the server, it says that this training server is connected to also 4 different MISP instances, and this event will be pushed to these 4 instances. I press yes. And if I reload the page, now you can see that the publish flag has been turned on again, and that the red font has disappeared because it has been published. Right.
Okay, that's basically it for creating it.
I think that's a good time to do a break. So we'll do a 10-minute break so that we say that we are back at 4 o'clock, but that would be Luxembourg or Brussels time. So see you in 10 minutes.
See you in. Okay, so welcome back, everyone. So let's continue where we left off. There was one question in the chat that will take a little bit of time for. So basically the question was, I understand that once an event is published to connected communities in MISP, it can't be revoked. And even if it is unpublished, it doesn't remove the event from the remote MISP instances. Could you please confirm if this is correct? Yeah, it's actually correct. So we don't revoke events once we publish them. So once they're gone, it's kind of like email. The reason why we don't do it in general is because we cannot trust other instances really to adhere to it. Anyone could capture the data in transit. Anyone could modify the code base. Anyone could enable email alerts, and then it would be in their inbox. So it would be misleading to say that you can actually revoke the information. However, there is something you can do if you absolutely want to do damage control over something that went out that shouldn't have gone out, and that's revocations. So when it comes to revocations of attributes, you can send out soft deletes across the network. So you could send out a soft delete. If we have an event already published and we deleted an attribute, it would go into soft delete state. And if we republish, it will remove the attribute also on the remote side, or it will set it to soft deleted on the remote side. There is also a way, if you absolutely need to get rid of stuff on all other instances, that you can do, and that is to switch to change or to mangle all the existing attributes. You could change an attribute's type to, or category to other, type to comment, and say redacted in the value and send it out as a modification. And that would actually overwrite the data also on the other instances. So that is the one thing you can do if something has gone wrong. But keep in mind, I mean, with email alerts and so on, the use of revocations for damage control are very limited. However, in terms of revocation, and that's the correct way of doing it, is it's revoking on an attribute and object level, not on the event level. Okay.
Now there was another question,
I didn't see that.
Which is, what is the goal of protected event experimental?
That's a good question. Yeah, it's no longer experimental. We should remove that. That's been there for 2 years now. So protected events, indeed, that's something we didn't talk about. It is more of a use case for communities where you might have adversarial relationships, so to say. So if you want to ensure that data does not get tampered with by other parties, then protected events help a lot. So the way it works is whenever I'm synchronizing an event out of my MISP instance, the data is tied to my organization. Even if it leaves the instance and goes to Sami's instance, for example, it would still be tied to my organization. However, if I shared my event with Sami and Sami decided to use an administrative account to modify my event and pass it on to someone else, it would be a tampered event once it arrived to a third party. in order to prevent this, we can use cryptographic signing to protect our events. So if you flip an event into protected mode, then your instance's signing key will be used to sign all the important data points within your event. And the event will carry over with a public key. And unless a modification comes signed with that public key, MISP will refuse the changes. So that this way, if you have a large mesh network of MISPs, you can avoid of modifications coming from unwanted direction. So that's basically it for protected events. In the future, we'll most likely also have protected sharing groups. That's next on our list. But the idea is really tamper-proofing, and especially with geopolitical changes over the past few years, we've had more and more needs for protecting events this way. But it really depends on the community. Okay.
There is another question.
Huh?
If you want to take it as well.
Yeah, sure. Which one?
So regarding tagging in MISP, you mentioned the potential long loading time when clicking on all. It's true. That can be true. Is there any recommendation or best practices in keeping the tag database small, clean with just the needed tags?
So first of all, I would not do that. I think that clicking all thing is annoying, but it's the only place where you get the slowdown from having too many tags. And it's still not too bad, but the biggest issue is really just, your browser will have to handle that many colored pills, and that's tricky. But generally for tags, I never use the all button anyway, because tags are more easier to find because the taxonomies are more straightforward than when it comes to, say, galaxy clusters. So generally, I wouldn't worry about that. However, with that said, you can reduce the list of tags there. We enable and disable taxonomies individually. So when you're an administrator, you can go to your list of taxonomies and you can decide which of those to enable. So generally, we don't like to make this decision based on quantity, but we really want to cover all aspects with at least one taxonomy that we want to describe. So just keep that in mind, that that whenever you're starting out with an instance, enable the types of taxonomies that you expect to be describing. And if it ends up being too much, well, just don't use the all button. But don't make that a priority. Rather focus on usability. With that said, enabling everything is almost never encouraged, simply because there are too many taxonomies describing the same concept, and too many taxonomies that are very particular to a sector. Yeah, exactly. Or the French national classifications. I probably would never use that myself because I'm not a French citizen. I'm not living in France. So I wouldn't enable this one. So rule everything out that you don't expect your community to use. I see there are more questions.
There is one, but I will reply in the chat. I think we can go on the searches.
Okay. Yeah, if you want to do it in the chat, sure. Then I'll continue with the searches. Okay. So for the searches, there are multiple ways to search in MISP. The main thing that you need to decide from the get-go is what scope you're going to be searching on. So this is true both for the UI and for the API. Think of it this way. If I wanted to find data in MISP, depending on the type of data I'm looking for, I would be looking at a different scope. If I wanted to, for example, find anything related to, or any events or incidents that relate to a certain threat actor, I would search in the event scope and I would get a list of events that match my criteria, and I would simply iterate through those. On the other hand, if I wanted to get all Bitcoin wallets that have been seen in any context in my MISP instance, I would search on the attribute scope and I would just search for all the attributes that match it. If I wanted to just generate a suricata export out of all the data, it might make more sense. Well, suricata is actually quite rich, so maybe not the best example. But if you were exporting in a format that only supported a few attribute types, then extracting entire events is overkill. So I would go to the attribute level in that case. Once we decided on the scope, we have multiple tools at our disposal. If we wanted to search on the event scope, the way that works is you have a quick filter on the right side of the event index that will basically search the field that you select there. Or alternatively, you have a more complex way of searching, which is that little magnifying glass button, very often missed. This one allows us to search by a bunch of different filters and construct a filter rule based on multiple things. So Sami is now showing an example with a time range, as well as only published events coming from a certain organization. You can use exclusions and inclusions via that little middle drop down. So we could say that instead of saying that we're interested in anything from Circle, we could say we don't want anything coming from that particular organization to be included in our hits. You have a lot of different use cases here. So you can search by tags to search for a threat actor, for example, or you can just have recurring searches from for all events coming from your organization that have not been published yet, if your role is doing last minute vetting of the data before they get pushed out. So just something to keep in mind there. You also get a little URL at the bottom that you can then bookmark if you want to keep searching for the same thing over and over. So if you come back every day to check whether there are more unpublished events for your org, this is one way of doing it. Now, what this will do is if we execute the query now, we will see why, yeah, now we don't find anything. It was pretty limited. So maybe let's remove the org limitation or the time limitation. There we go. So now we have a filtered data set, and we can come back to this URL anytime. Now, again, this only gives us a list of events. So if you wanted to have a list of Bitcoin addresses, for example, this wouldn't help us. In that case, we'd use a search attribute functionality. Here we have a bunch of different fields that we can use for filtering. So the expressions would be searched in the value fields of MISP. You have the tag filters that you can use, IDs, organizations, types, categories, and so on and so forth. All of these are where you see the text entries are basically multiple entries, so one entry per line. And each line can be prepended with an exclamation mark to mark it as a negative filter. So we could say that we don't want anything from TLP red. That would work the way that Sami has now shown it. Or you could also use wildcard characters. So you could search for TLP double points modulo. And this would find anything that has a TLP label. But in the next line, we could say, but exclude TLP red. So this would now find all events for us that are labeled with a TLP tag, but that are not TLP red. So you can mix and match these different filters this way. You can also add multiple things, so you can further restrict it by saying, okay, I don't want anything TLP red, but I require TLP markings, but also exclude Circle, for example, if I'm really interested in data coming from other parties. Okay. That's basically it for the simple UI searches. However, even though these are quite flexible, you get way more flexibility if you do it via the API, but Sami will show that in a bit. Something maybe to note here is once you have run your search, like Sami did now, at the bottom of the list, you have the functionality to basically export all the hits in any of the supported formats of MISP. Again, this is a dynamic list, so if you add additional export formats or enable modules, you would have other formats there as well. But basically, this will then retrieve everything that is matching your criteria. A little bit misleading. What you see here is a paginated result set. So we are currently on the first page and we could keep paginating until there is no more data. But the download result as thing will get everything that matches your criteria. So it will get all the pages in one shot. Okay. And there is another question. So the question is, I would like to use MISP as a source of information. Oh, whoops.
I jumped because I just replied.
Okay. on malicious domains or URLs, such as those associated with botnet command and control servers. Okay. So that's that indeed helps. Let's do it in multiple steps via the UI first. So let's just look at that example. So if we go to search, so here you mentioned malicious domains or URLs. Via the UI, we can only do one at a time, so we'd have to run 2 searches. So let's do the first one now, and then we'll see that you can actually do that via the API in one query. So if in type, let's just select domains for now. You also mentioned botnets, so you can do modulo botnet modulo in the tag filter. That will grab. Okay, this is a very naive approach, but this will now look for any label that has botnet mentioned in it. Again, if you know exactly which tags you're interested in, so I don't know by heart botnet command and control servers what tags exist for it. That's why I cheated here by doing this.
This is a quick and dirty.
This is a quick and dirty thing indeed. Let's not go through it because we're going to run out of time.
Yeah.
But let's go back to search instead. Yeah. And now if we run this search.
Don't forget the ITS one, because
yeah,
it was mentioned
malicious.
that it's malicious.
Indeed. So then we run the search query and we don't have anything in this instance that matches it. But if we did, then we could select the export format below and then just export our data. Again, this is UI. I would do this via the API anyway, because you have way more control over it. And also, and just a little tip, if you're more familiar with how MISP works, I generally use the API via the built-in REST client in MISP whenever I want to find anything, basically. That gives you way more flexibility than any of these searches that we've seen. It also allows you to search on an object scope level rather than just attribute and event. And it also generates a curl query and a PyMIS script for you if you want to basically run the same queries outside of MISP.
Yeah, I think it's important that we show that. So we'll show it.
We'll go through it. Yeah, okay. Okay, so that's basically it for the searches. What did we not have yet?
I
think that's pretty much it.
There is just the enrichment that I would like to cover before we go over the API.
Go ahead.
So let's actually take our event, the one that we created before. All right. And so you can see in the table that for some attribute values, we have a small magnifying glass next to it. So we have also it for the email, for the IP address, for the domain. This means that for that specific instance, we have an enrichment module that is enabled that can be run on that value. So let's have a look with our domain. So you could either click on this magnifying glass to perform the enrichment. And what this will do, it will basically loop through all the modules, enrichment modules that we have enabled for the attribute type domain and perform the enrichment. So we can see country code commercial. We have an entry for DBL SPOMOST. And the DNS and URL host module returns nothing because this is a non-valid domain that actually is completely fake. Let's have a look for the IP address. And we can see for the IP address, we have some results for geolocation telling us that it's based in the US. We also have the ASN number with the description also. So this is nice, but it's not saved in the event. See, when you do the enrichment, you see the information on the screen, but it's not saved inside your event. You can choose to save it if you click on this small asterisk icon. If you click on Add Enrichment, then you can choose which enrichment module you want to run and save. So for example, I will use the MMDB lookup. This is the one that allows me to do geolocation. So when I click on it, MISP is going to use the enrichment system from MISP module, send the value of that attribute, so the IP address. And then what I'm seeing on the screen is basically the output, so the result of that enrichment query. So we'll see we have the ASN number, and we have two geolocation objects. They look almost exactly the same. The only difference I see is the build of that geolocation DB. So since it's the same, I will just take the latest one. So I will uncheck this object so that I don't save it twice. You hit submit. And then you can scroll down and you can see that we have our geolocation ASN numbers correctly added. Right. So that was it for a quick overview of the enrichment system. So I will show you just the repository so that you have a nice overview of what kind of enrichment modules are available. Do we have, oh, we actually have a website. Yeah. I will share the website in the chat so that you can have a look later on. And you might recognize some of services that you can find online for which we have an enrichment module like Abuse APDB, Backscatter.io, Census Enrich, ClamIV, CrowdStrike, CV Lookup, DNS Resolver, GeoIP Lookups, Intel 471, JOS Sandbox, McAfee, MalwareDB, so on and so forth. So you can see we have quite a few. So this is for the enrichment, and then for the export modules are like the export format that Sandra showed with allowing you to export under Suricata, CSV, and so on. But these are formats typically used in other tools like Microsoft Defender, Cisco, Fireside, I don't know, the OS query, so the one described there. So this is for the export, so to transform from the MISP format into another format used in other tools. And we have the other way around, like import modules, so to take the output of these tools and save it into your MISP instance. All right. So if you're using one of these services and you would like to have them as MISP module, do not hesitate to either ask the vendor to contribute to our MISP module repository, or you can also ask us and we can see what we can do with that. All right, so let's now talk a bit about the API. So Andras mentioned the built-in REST client that we have in MISP. So let's cover that. So when you're in MISP, you have on the navigation bar under the API section, you have Open API and REST client. So the Open API is basically just the documentation that we host on the website. So we have so it's hosted on your MISP instance, but you can also find it under our website on mispproject.org. So it's basically the documentation regarding all the different endpoints, how you can use them, which parameter they accept, so on and so forth. And the REST client, also the playground on which you can play with MISP API. This is where you can like fine-tune and use that tool as a workbench to craft your queries, try them out, and get the output. You also have a bit of documentation built in. Like you can select a template. For example, if you want to export attributes or to search for attributes, you simply go in the template, search attributes, and then you will be able to describe all the search parameters. All right, let's have a look at what we can do. And we'll start with attribute REST search. So in order to interact with the MISP API, well, you have to prove that you are authorized to use the MISP API first. And so you have to have an API key. So an API key, you can get it quite easily. You just click on your profile. Then you scroll down under the auth key section. You click on add authentication key. For this one, you can add a comment so that you know which tool is using this API key. You can provide some allowed IPs. You can provide expiration date. For example, I will add today. So that would be, and then you hit submit. And then you will be presented with the API key only once. Because afterward, this API key is going to be hashed and I don't have put today. Let's do it again. Oops. Because you will only have it partially accessible. So yeah. Once you have this API key, now you can start to play with the API. So you take your API key, you select first the HTTP method that you want to use, so get or post. Press search for attribute accept post. Then you provide the API key under the authorization header. You can, if you have self-signed certificate, you can skip SSL validation. If you want to see the result of your API query, you can enable the show result option. And then you provide the filtering parameters. So let's get rid of everything and let's do a really simplistic search. The first one is you could specify the format under which you want to get your output. So just to show an example, I will use JSON. And then you can ask, for example, to extract the types. So if you want to get all domains and all IP addresses, you do something like this. And if you want to also filter on tags, you could say that you want to extract anything that is TLP clear and TLP green, for example. Once you are happy with your query, you hit run query. And then it's going to run. You can see the response code. I see success. I don't see the content because I didn't click on show result. So if I would click on show result, I run the query again. This happens when you have your instance badly configured. And then oops, I didn't bookmark it. See, you also have it in the query history, which is quite handy because now I can replay it in a few seconds. Now you can see I have the result. These are all the attributes that are matching my filtering. And last bit that is really cool is the curl and PyMISP helper that you have. So Andras mentioned it already. So it was a bit, were a bit spoiled. But basically, MISP generates you a curl command and a PyMISP command that you can simply copy paste and immediately run it, and you have the output directly. So you can see how straightforward it is. So if I want to just extract all attribute values to have all IP addresses, for example, I can use GQ to process my JSON, extract only the value for each attribute, and then probably pass them through bash pipeline unique sort, and I'm good with that. So that would be for curl, and for PyMISP, it's just generate Python code that I can copy paste and just have the output of that call save the output of that call into a variable, and then you would have all these attributes accessible in your code. All right, I have prepared a Jupyter notebook to show you more example on how to use the API, for example, to create information and to search for information. These notebooks are accessible under our MISP training repository. So we also have a repository for all the training resources. I will paste it in the chat so that if you want to play with it later on, you can do it. All right. So it looks like I'm gonna, oh, this is by MISP, hold on. This is the wrong one. Yes, this is the one. It looks like I'm going to execute some Python code, but actually I'm just using Python to issue the request. But what's really happening behind the scene is I'm hitting directly the MISP API. The reason I'm using Python is first to issue the request and second to parse it so that I can access the amount of attributes that were returned and so on. So the first thing that you could do, for example, is to create an event. So by using the event/add endpoint, I can provide some content for that event. So if you remember, when you create an event, you have to provide the event info field. This is this field. And you can provide optionally the distribution and the thread level ID. So in that case, I'm providing this information. And if I execute the query, you can see what I got as a response. I got the entire event object that was created. And what's really handy when you get that output is that you have the ID and the UID of that event so that you can save that information and reuse it later on if you need to interact with that event further down the chain. So now if we go back to our MISP instance, you can see that now I have my event created via the API as an example. That's exactly the title that I put there. That has been created, as you can see. So what else can we do with it? Well, first, we can edit that event. So if I use the event edit endpoint, I can change the distribution. So let's pick something like distribution 2. I can change the distribution. You can see right away I got a warning, this event view is outdated, please reload. And you will see once I will reload the page, the distribution will change from your community, your organization, sorry, to connected communities. So what else can you do? You can also attach tags. This is an endpoint that allows you to attach tag to any object. By object, I mean it can be an event or an attribute. So it takes as input the UID of the element you want to attach the tag to, and then the tag. So the output is global tag TLP read successfully attached to event. And now if I reload, you can see that the tag has been attached. Now, what else can you do? Well, obviously you can add attributes because an event without content is useless. And so to attach or to add an attribute to an event, you can use the endpoint attributes/add, and you have to provide the event ID for which you want to, in which you want to create the attribute. So in this case, I'm creating an attribute of type IP destination with this value. So if event ID is not defined, you have to define it first. All right. Now, if I call this, well, if I do this request, similar to whenever you create an event, you will get the attribute that was created, which is really handy because you get the ID and the UID as well. And now if we go back to our event and we refresh, we can see that we have created that attribute. So one comment, what happens if you try to create an attribute for which the value does not satisfy the validation that we have enforced for the type? For example, now I'm trying to create an attribute of type MD5, which expects a valid MD5 hash. And if instead of a valid hash, I put this IP address, MISP will not be really happy and tells me that it couldn't add the attribute. And it gives me the error that, that was written by MISP. So similar to event, you can also edit your attribute, really similar to what we did so far. You just, instead of event edit, you use attribute/edit, and you can change whatever you want. I will show you one last time how it works. So you just provide the ID of that attribute, and the different field that you want to change. So from 8889, we'll switch to 127001. And now if I reload, you can see that the value has been updated. You can also attach, or rather create object inside your event. You can see that it's way more verbose than it is for attributes. If you want to create an object, this contains actually more information that is required, like this one you could remove. This one you could remove. But it's just to, let's say, invite you to use MISP instead of using the raw MISP API, let's say, especially if you're trying to create object, because MISP has a lot of helpers that allows you to really manipulate this data structure quite easily. But you can still do it like so. So now if I reload, you will see that I have created my object. You can also create event report. You can create analyst data. You can create opinion, so on and so forth. Now let's have a quick look at searches. So searches, you can view the different way to search the same way we did using the UI. So you can search on this list of events. That would be by using the event index endpoint. And on this endpoint, you can use any parameters that were accessible in that list. You can use them in the as a filtering body. For example, the published at, where you can put a start and end date time. You can do the same by using the published timestamp. And this 24, it's relative time. It means 24 hours ago until now. For the event info, this is basically the title. So that would be event info. And same for organization. I'm not sure if I will get a result. No, I won't get a result. Because most probably this event hasn't been published. But now you can see that I have one result because this event contains the word API in it. And the organization that created this event is called org name. So you can also filter if based on tags. So get all events that have the tag tilpy green attached to them. So you can see we have 11 of them. Yeah. So if you want to see what you can do with the event index endpoint and which filtering parameters and how they can be used, I will refer you to the OpenAPI specification that you have for that endpoint. Now, the most powerful search tool that you have in MISP, also called ResSearch. This ResSearch can work on multiple scopes, as was already mentioned. It can work on attributes, it can work on event and object. So let's see another example. So right now, I'm doing a search to get all attributes that are from event 243, and I want to have them under the JSON format. You can see that I got two attributes because we indeed have two attributes. We have this IP address and this post. I could also ask MISP to get all attribute of type either IP destination or IP source from that event. If I do this, I got one attribute. This is totally expected because we only have one. I could also remove that condition event ID and get, in this case, all attributes that are of type IP destination, or IP source. This can lead to a lot of attributes. So let's further refine which value they can take. And with this, I'm basically asking MISP to get all attributes of this type that start with 127.0 dot. And if I do this, you can see that I have one. All right. A lot of other examples on how you can search for tag using res search. So we can search directly by providing the tag as is. You can provide it with a list. So a list basically means TLP white or TLP red. Similar to the UI, you can also provide negation. So to say, okay, I don't want to have any attribute that are labeled with TLP red. And you can also use the wildcard to have all attributes that have a TLP tag or that have a tag that start with TLP double point. All right. One of the last important piece that I want to put a big emphasis on is the pagination. So what happens if you try to do this? So to ask MISP to search all attributes and to get them under JSON. Well, what you will actually do is to basically dump the entire attributes table. In this case, we have a small training instance. I don't know how many attributes we have, maybe a few thousand. Maybe it's going to be okay. But if you do it on a production instance, which has millions of attributes, you are going to have an issue. Like the session will time out, the request will time out. It's not going to work. So if you want to export everything, you have to paginate your queries. And to do that, you have to use the page and limit parameters in conjunction. So in this case, I can ask for the first 10 attributes on page 1. You can see I got 10. And then I can ask on the next page, I got also 10. And you keep increasing this page until you run out of attribute. At some point, you will not have any attribute left. And so you will be done exporting your data. So that's just something to keep in mind whenever you are paginating. All right. If we are missing anything important, this is not really interesting. Okay, maybe just one last one before we switch to PyMISP. And this is the enforce warning list. So for this one, I will add 8888 so that we have a good example. So now you see we have a warning for this specific attribute. So what happens if I try to export all attribute of type IP source and IP destination from that event? You see I have two attributes. Obviously, I have this one and this one. But I can also ask MISP to remove or to cull any attribute that have a hit on a warning list. And to do it, I simply add this parameter enforce warning list set to 1. And if I do it now, I will only have one attribute, which is the one that doesn't have a hit, basically. All right. Now for PyMISP. This one. For PyMISP, I will also provide the notebook. So the notebook is under docs, tutorial, full overview. So this is the notebook for PyMISP if later on you want to play with it. So what we are going to see is first how to use PyMISP to generate data offline. So basically we'll create an event, we'll add attribute, we'll add tag, but it's not going to be created on MISP side yet. So we'll just generate and create our data. And once we are done, we're gonna push it in one shot on MISP. So this is what this first example tries to illustrate. So we import a MISP event class, so it's just basically an import. And then we create this event inside this context. We assign the different fields, so the information and so on. And if we print this one, you can see that PyMISP automatically generates an UID, an ID, what am I saying? Generate a UID. Then on this very event that we created, we can also attach a tag on it. In this case, that's what I'm doing with a tag. So now you can see we have a tag attached to it. But since we are dealing with a Python object, we can also use some function, for example, to change the date. But yeah, I mean, you can use datetime and such if you want. You can also add attribute into this event that we created. In this case, I'm simply adding an IP destination with value 8888. So you can see as return, the value returned by this call is actually an attribute, like a MISP attribute from the PyMISP library. And if we have a look at what's inside this attribute, we can see that the category was automatically derived from the type that we passed, and we also have the UID. So later on, this attribute, we can also change its value. For example, if you want to turn off the IDS flag, we can do it like so. We can also attach tags to this attribute, either by accessing the attribute in the event and adding the tag, or by simply using the attribute that was returned by the call, add attribute, and attaching the tag to that attribute. We can also delete, we can also mark an event as published. Yeah, these are other examples on how you can create an attribute. This is also an example on how you can create an object. You can see that it's way easier to create an object using PyMISP than using the raw MISP API. You simply declare which object template you want to use, in this case, domain IP. And once you have your object created, you can add attributes to that object. And finally, add this object to your event. We can see that our event is growing slowly but surely. And so far, this event is still not on MISP, right? It's just in the context of execution of our script. So this notebook also shows other helpers that you can use to generate objects and to help you create objects. Yeah, this is okay. Let's keep that. That's interesting. And now comes the interesting part. It was interesting before, but now it's even more interesting because this data that we have created, now we will push it to MISP and we will interact with our MISP instance. So I will to do that, you have to create a PyMISP client for which you provide the URL of the MISP instance, the API key, and if you want to verify SSL certificates. All right. And now we can start to interact with a MISP instance. So let's see. The event we created before is contained inside this event variable. And what I will do, I will simply call misp.addEvent. I'll pass the event that I created. And that should create the event on MISP side. So now if I reload, can see that I have, this is my new MISP event. And if I explore this event, you can see that I have the different things that I've created. What I can also do is also improve this event. For example, now I'm creating a file. I'm adding file name to that file object. And then I'm updating my event with that, with these changes. You can see I got that as a response. And if I reload, you can see that the file object has been created on my event. So there are many ways on how you can interact with MISP. So you could either create everything in the context execution and then send it to MISP, but you can also just call the add event function to create an event right away, like I will do right now. So now you can see if I go back to my MISP, now I have created my event from notebook, which is empty. You can get an event. For example, this event is 2:45. You could also get an event if you provide the event ID. This show example on how you can play with proposals. We haven't talked much about proposals, but it just shows examples. How you can also update existing events by simply getting the event by ID, creating data, and updating the event. How you can add sightings. And finally, one really cool trick. As a developer, I love to use it. Is the direct call, and I see Andras laughing as well, because both Andras and I, we are the MISP developer. We are not the PyMISP maintainer. So sometimes we are not really sure, and we are lazy to read the documentation. I'm gonna be honest, on how to use some endpoints. So to do that, we simply use the direct call functionality from PyMISP, where we pass the URL endpoint and the payload, and then PyMISP does the rest. So it executes, it authenticates correctly, executes the query, and returns the result into our Python script. So it's this one is super handy, and it's actually the one that is used by the REST client. So you can see we kind of cheat. We don't have a mapping for all the different endpoints that so that they use the correct PyMISP function. No, we just use the direct call because we are lazy and it works well within PyMISP. So we do it that way. But still, a lot of way to do it in the Pythonic way, let's say, or to use built-in PyMISP features like managing users, managing organization, and so on. But we are not going to cover that today. I think it was already a good overview. And with that, I think we are done for today. It was a rather short but intense session. So if you have any question, feel free to ask them in the chat. And with that, I wish you a very good day. And thanks for joining.
And see you tomorrow.
Indeed, indeed. Tomorrow, this session was targeted to users and basic usage. And tomorrow it will be about admin. So basically setting up synchronization, managing your users and organization, settings of MISP, and so on. So thank you very much for joining, and have a pleasant day.
Thank you all.
Bye-bye.
Have a good one.